Let us now talk about the different data analysis techniques. Data analysis helps to extract valuable insights from collected data. The choice of technique depends on the nature of the data and the specific objectives of the analysis. Each technique provides a different lens through which to understand the data, and often multiple techniques are used in conjunction to gain comprehensive insights. In the realm of project management, data analytics plays a crucial role in enhancing efficiency. Here are some key data analysis techniques used in project management. Let us look into these in detail. Descriptive analysis summarizes raw data to make it interpretable. It includes calculating measures of central tendency, dispersion, and frequency, and visualizing data. For example, consider past project completion times of 10, 12, 9, 15, and 11 weeks. Here the mean is 11.4 weeks, the median is 11 weeks, and the range is 6 weeks. Such analysis aids future project planning and management. Prescriptive analysis is an advanced form of analysis that uses optimization and simulation algorithms to advise on possible outcomes. It is used in project management to recommend actions that can lead to optimal project outcomes. For example, it involves using optimization models to determine the best allocation of resources. For instance, for a project with tasks A, B, and C, each requiring varying time and resources, it can optimize schedule and resource allocation, minimizing costs and time. Techniques like linear programming or machine learning algorithms can be used to find the optimal solution. Predictive analysis uses statistical models and forecasts to understand future performance. It's often used in project management to predict project outcomes based on historical data. For example, a project manager can leverage predictive analysis to forecast a new project's timeline and resource needs, aiding in planning and risk management. It can also identify potential project bottlenecks or delays using techniques like regression analysis, time series analysis, or machine learning algorithms. Diagnostic analysis is used to understand why something happened. It involves drilling down into data, finding patterns, and identifying anomalies. For example, when a project consistently misses deadlines, diagnostic analysis can be used to examine task completion rates, team member performance, and resource allocation. This analysis can help identify workflow bottlenecks or inefficiencies, enabling project managers to take corrective actions such as reallocating resources, adjusting timelines, or supporting team members. Exploratory analysis involves analyzing data to find patterns or relationships without having a specific hypothesis in mind. For example, through exploratory analysis, a project manager can study task completion times across teams or departments. This might include creating histograms or scatter plots or calculating mean or median completion times. The insights from this analysis can aid in project planning and decision making, such as pinpointing areas needing additional resources for efficiency. Regression analysis is a statistical method that estimates the relationships among variables. It is often used in project management to understand how the typical value of the dependent variable changes when any one of the independent variables is varied. For example, a project manager can use regression analysis to forecast project completion time considering factors like team size, project complexity, and budget. This aids in planning and resource allocation, enhancing project management efficiency. Monte Carlo simulation is a computational algorithm that relies on repeated random sampling to obtain numerical results. In project management, it is used for risk analysis. Imagine a project manager facing a complex task that could take 10 to 20 days. By applying Monte Carlo simulation, they can simulate thousands of scenarios, each with a random completion time within this range. This results in a probability distribution of completion times, aiding in decision making and risk assessment. Factor analysis is used to reduce a large number of variables into fewer factors. It helps in data simplification and summarization. For example, in a consumer behavior study for a new product, factor analysis can identify unobserved factors like price sensitivity, brand loyalty, and product quality from observed variables like product features, pricing, and brand perception. This helps in understanding different customer segments and guiding targeted marketing strategies. Cohort analysis involves grouping related types of data to understand trends and patterns over time. For example, it can be used to group projects based on their initiation year and track their performance over time. This can reveal patterns and provide insights for future project planning and execution. Cluster analysis involves grouping a set of objects in such a way that objects in the same group are similar to each other than to those in other groups. For example, it can be used to categorize projects into clusters based on features like project size, duration, or cost. This can help in identifying patterns, optimizing resource allocation, and tailoring management strategies for each cluster. Time series analysis involves analyzing data points ordered in time to identify trends, seasonal patterns, or other systematic changes in data. For example, it can be used to forecast project variables like costs or resources over time based on historical data. This can aid in better planning and risk management for future projects. Sentiment analysis is used to systematically identify, extract, quantify, and study affective states and subjective information. For example, it can be used to gauge team morale or stakeholder sentiment based on communication data such as emails or survey responses. This can help identify potential issues and improve team dynamics.